Hi, today we'll be talking about the second part of exploring data, spotting problems using graphics and visualization. Information like the peak age of the distribution, the existence of subpopulations, and the presence of outliers is easier to absorb visually than it is to determine textually. The use of graphics to examine data is called visualization. There are some principles that have been given by William Cleveland for scientific visualization, which are: a graphic should display as much information as it can with the lowest possible cognitive strain to the viewer. Strive for clarity, make the data stand out. Visualization is an iterative process. During the visualization stage, you graph the data, learn what you can, and then regraph the data to answer the questions that arise from your previous graphic. Different graphics are best suited for answering different questions. This is an example of a graph. Some information is easier to read from the graph than from summary. So as you can see here, this is a graph in which age is plotted against density, and we can see the peak of the customer population is just under 50, which is not so obvious from the summary. The first part in this portion is visually checking distributions for a single variable. What is the peak value of the distribution? How many peaks are there in the distribution? How normal is the data? How much does the data vary? Is it concentrated in a certain interval or in a certain category? These are the questions that can be answered using distributions for a single variable. This is an example of a unimodal versus a bimodal graph. A unimodal distribution can usually be modeled as coming from a single population of users. With a bimodal distribution, your data often comes from two populations of users. The first type of graph that we'll be discussing is the histograph. A basic histogram bins a variable into fixed size buckets and returns the number of data points that falls into each bucket. The primary disadvantage of histograms is that you must decide ahead of time how wide the buckets are. If the buckets are too wide, you can lose information about the shape of the distribution. If the buckets are too narrow, the histogram can look too noisy to read easily. The given instructions here shows how to plot a histogram using R. The first thing that you have to do when you're using R is to load the ggplot2 library. For using this library, first we have to install the package ggplot2. There are two ways in which you can install packages in R. Either we can give the instruction directly into the console, or just go to Tools and Install Package from there. Next is the density plot. You can think of density plot as a continuous histogram of a variable. A point on a density plot corresponds to the fraction of data that takes on a particular value. When you look at a density plot, you're more interested in the overall shape of the curve than in the actual values on the y-axis. When the data range is very wide and the mass of the distribution is heavily concentrated to one side, it's difficult to see the details of its shape, such as the exact value where the income distribution has its peak. If the data is non-negative, then one way to bring out more detail is to plot the distribution on a logarithmic scale. The next one is bar charts. A bar chart is a histogram for discrete data. It records the frequency of every value of a categorical variable. The figure shows the distribution of marital status in the customer dataset. Bar charts are most useful when the number of possible values is fairly large. This is a horizontal bar chart which can be easier to read when there are several categories with long names. Sorting the bar chart by count makes it even easier to read. So, as a summary, there are three types of graphs which can be used for visualizations for one variable: histogram, density plot, and bar chart. We now move on to the next part, which is visualizations for two variables. When there is a relationship between two variables, we have to find the answers for the following questions. Is there a relationship between the two inputs, age and income, in my data? What kind of relationship and how strong? Is there a relationship between the input marital status and the output health insurance? How strong is that relationship? The first graph we'll be looking at is the line plot. Line plots work best when the relationship between two variables is relatively clean. This is the way to plot a line plot in R. Next one is scattering plots and smoothing curves. This is how we examine the correlation between age and income. We find that the resulting correlation is minus 0.22. What is the relationship between age and income? The appropriate summary statistic is the correlation, which we compute on a safe subset of our data. This is how a scatter plot is plotted of age versus income. We can make this relationship clearly by plotting a linear fit through the data. We can better capture the shape by instead plotting a smoothing curve through the data. A scatter plot with a smoothing curve also makes a good visualization of the relationship between a continuous variable and a Boolean. This graph shows the distribution of customers with health insurance as a function of age. If the data set were 100 times bigger, there would be so many points that they would begin to plot on top of each other. The scattered plot would then turn into an illegible smear. In high volume situations like this, it is better to use a hex bin. This is the example of a hex bin which has been plotted on income versus age with a smoothing curve superimposed to show the difference. Next type of graph is the stacked bar chart. Here we see health insurance versus marital status. Next one is the side-by-side chart. Again using the same two variables, health insurance versus marital status. The next one is the filled bar chart. So you can see how these three charts can be plotted using R. Next one is the filled bar chart with the rug. The next one is side-by-side bar chart. This is the distribution of marital status by housing type. Then we move on to facade side-by-side bar chart. This is a summary for all the graph types that we see for visualizations for two variables.